Alright, so here we go with the practice for the Mod 10 test. Graph the inverse of the graph defined by the given points. So all I have to do is I need to take the points and I need to flip them. So instead of the point -3, 4, it would be the point 4, -3. Instead of the point -2, 2, it would be 2, -2. Instead of the point 3, 2, it would be 2, 3. And instead of the point 4, 1, it would be 1, 4. Now, I believe on the actual test they're not lines connecting them, so you would literally just plot the points. 4, -3, 2, -2, 2, 3, and then 1, 4, and you would be done there. Now this one does have lines connected, so I do need to connect my lines here. But if it's just points, then don't connect the dots, just graph them and be done. Okay? Now, is the original on graph number 1 a function? So looking at the original graph, which is the black one right there, I'm not going to look at the pink one. Is it a function? In other words, will it pass the vertical line test? The answer is yes. It passes the vertical line test. Now, if I just have an original and I want to know if the inverse is a function, I can either use the vertical line test on the inverse, or I can look at the original one and say, is it going to pass the horizontal line test? I don't think so, because if I drew a horizontal line right here, do you see how it's going to touch it a lot of times right there in that straight part? So, is the inverse a function? No. And the reason is the original graph fails not the vertical line test, because that's what we did to check if the original one was, the horizontal line test. Okay, so that's my reasoning there. All right, number 3, find the inverse, then graph the original and the inverse. For each graph, show an XY table of values as directed by your teacher. I don't believe, I personally don't require an XY table. I'm going to go ahead and graph the original one in pink. So let's see, I have a y-intercept of 4, so I'm going to go graph that point of 4. And then I have a slope of -2/3. So that's my rise, which means I go down, and my run means I go right. So down 2/3, down 2/3, and 2, 3. And it's best if you can use a straight edge. Your ID card is a perfect straight edge for these guys. Okay? Now, when you are graphing linear inverses, such as these, they should intersect on that line y equals x. Okay? All right, I'm going to use, let's see, how is this color? Oh, I think it'll be okay. I'm going to use green to find the inverse. So for step 1, I replaced the f of x with a y. So I'm going to call this y equals -2/3 x plus 4. I need to start off by getting x by itself. So I'm going to subtract 4. So I have y minus 4 equals -2/3 x. And how do I get rid of the -2/3? Well, I have to multiply both sides by the reciprocal. The reciprocal is going to be the same sign, so it's also going to be negative, but it's going to be 3/2, and that's what I'm going to get. So I have -3/2 y. Then I have to multiply the -3/2 also by the -4. So if I go to my calculator, -3/2 times -4 is 6. And I have x. So I have -3/2 y plus 6 equals x. And the last step in finding an inverse, before I write my answer, I have to change my y to an x and my x to a y. So I have -3/2 x plus 6. That is my inverse right there. And now I'm going to graph it. Y-intercept is 6, so that would be right here. I'm assuming it's going to be coming down because it's going to have to intersect the pink line on that line y equals x. So let's see, down 3 over 2, down 3 over 2. I think it's looking pretty promising that it's going to intersect there. So let me grab my ruler and draw my line in. And I draw my arrows on the end, and there is that intersection right there on that line y equals x. Okay? All right, same thing on the next problem. I'm going to start off by graphing the original one in pink. Y-intercept is 8, so I start all the way up there. My slope is 4, so that means 4 over 1, so I go up 4 and over 1. Now there's a problem. I can't go up 4 and over 1. So I need to think of what point was it before that they went up 4 and over 1 and ended here. Well, that would be somewhere down here, right? Wouldn't it be here if they went up 4 and over 1 and ended up there? So I'm going to kind of work backwards. I think right there. So let's see if that follows this pattern. Up 4 over 1, up 4 over 1. So if you're going to be at a place like this where you can't graph it on there, it's going to be off the graph. Think of what came before and work backwards. That'll get you the points that you need for your graph. Or you can always do an XY chart. Okay, so I'm going to graph this the best I can. And again, the inverse should intersect it then right there on that line y equals x. So here's my line. I'm going to do y equals 4x plus 8. So again, my first step is get x by itself. So I'm going to subtract 8. Y minus 8 equals 4x, and I'm going to divide by 4. I have to divide everything by 4. So I have y over 4, which we would call 1/4 y, minus 8 over 4 is 2, equals x. And then my last step is to switch the x's and the y's. So I have 1/4 x minus 2 as my answer. So my y-intercept is -2 down here. From there, my slope is 1 over 4. So I'm going to go up 1 over 4, up 1 over 4. And I'm going to connect my points. And again, there they are. They're intersecting each other on that line y equals x. Okay, so there's my first page with my inverses. So now let's graph some square roots and some cube roots. No straight edge needed for these guys. Okay, so these first two are square roots. The second two are, I'm sorry, that's not true. We have a cube root, a square root, and a cube root. So either one, the first thing I need to do is find h and k. So in this situation, h is 0 because h would be in the radical, and k is 4. In a cube root, that's always my starting point, 0, 4. Okay? Now remember, in cube roots, think of your cube numbers. 1 cubed is 1, 2 cubed is 8, and so on and so forth. So I want to go 1 away from there, so that would be -1 and +1, and I want to go 8 away from there. So 8 away from 0 would be -8 and +8. That'll help me keep nice numbers as I'm doing this. So let's plug it in. Negative cube root of -8. Let me put that in parentheses just so that it knows that the +4 is actually outside the radical. And I get 6. Now I'm going to arrow back. I'm going to change the -8 to a -1. And I get 5. I'm going to change the -1 to a +1. I get 3. And I'm going to change the 1 to an 8. And I get 2. So again, by doing that pattern of the 1 away and 8 away, that's going to keep me in the nice number range. So let's graph what we've got going on here. -8, 6 is up here. -1, 5, 0, 4, 1, 3, and then 8, 2. So my graph, don't do straight lines. Make sure that you've got a little bit of a curve to it. Got a wiggle. There's a gentle curve in there. That's what my graph looks like. So, domain, it's going left and right, no stops. That means all real numbers. Range, it's also going up and down. No stops. That means all real numbers. X arrow infinity, that's asking about the right side. What's going on the right side? It's going down. X arrow negative infinity is asking about the left side, and that is going up. Then finally, describe how the parent function is transformed. Well, if I have an a value of -1, I have a vertical reflection. I have no h value to worry about, and my k value is 4, so I have a shift up 4. That's my description. Okay. All right, I'm going to jump down here and do the next cube root. Then I'll look at the square roots. So in this one, h is -2 and k is 0. So my middle point here is -2 and 0. Again, I want to go 1 away from there. So what's 1 away from -2? Would be -3 and -1. And then 8 away. 8 away from -2 would be -10. And then 8 away the other way would be +6. That's how I fill in my values there. Now I'm going to use my calculator to plug stuff in. I have the cube root of -10 plus 2. And again, let's go ahead and put that in parentheses because it doesn't automatically. That way it knows that 2 is in the h value inside the radical as opposed to a k value outside. And I get -2. Now I'm going to change that -10 to a -3. And I get -1. Now I'm going to change it to a -1. I get 1. And now I'm going to change the -1 to a 6. And I get 2. So let's see what that looks like. -10, -2, -3, -1, -2, 0, -1, 1, and 6, 2. So again, we have a gentle curve coming in here. And we've got something going on like that. Cubics, again, domain and range, both all real numbers. Then we have to look at what's going on. On the right side, we're going up, and on the left side, we're going down. Then finally, describing my transformation, the only thing going on here, there's no a value, no b value, no k value. The only thing going on here is an h value. Since my h value is -2, I have a shift left 2. Okay. All right, now let's move on to square roots. I'm going to start off with this square root up here. Okay, what is my h value? -5. And what is my k value? -1. So -5, -1 goes in the middle. Now I'm not going to do 1 away and 8 away because remember that was 1 cubed and 2 cubed. I'm doing square roots, not cube roots. So I'm going to do 1 squared, which is 1, and 2 squared, which is 4. It's 1 squared and 2 squared. So I want to go 1 and 4 away. So 1 away from -5 would be -6 and -4. And 4 away would be -9 and -1. Now, if you remember with square roots, one of these directions, either the -9 and the -6 or the -4 and the -1 are going to give you imaginary answers. So I'm only going to get 2 out of those 4 missing spots there. So let's see what we've got. If I start with -9, 2 times the square root. Notice I didn't use the x radical. I'm not doing that. I'm doing 2 times the square root of, let's do -9 plus 5, close my parentheses, -1. Error. What does that tell me? That tells me this is the side that has imaginary numbers. And I could go back if I wanted to plug in the -6 and I'll also get an arrow. Oops, -6 plus 5, and I'll also get an error. Okay? which means that the other side should be good. If I put -4, we're good. We've got an answer. And -1, we're good. We've got an answer. So that's kind of like a wall right there. -5, -1 is my starting point. I can't go any further. I can't go towards -6 or -9. So I start there. -4 goes to +1. And -1 goes up to 3. So if you can see, it's going to start here, and it's going to continue on that way. Now, it is important. It cannot go through that point and head to the left any further than that. It's done. Okay? It's half a parabola, and that's what I've got going on. So, domain, left to right. Right, it's going on forever, but it definitely has a stopping spot on this side. So all of my x values are to the right of -5, which means that all of my x values are greater than or equal to -5. It also has a stopping point up and down. It's going to keep going that way, over and up. But down, there's nothing that is below -1 for a y value. So all of my y values are greater than or equal to -1. Okay? Also on this one, my end behavior, one side is going to be crossed out. So let's think about this. My graph is going to the right. So on the right side, it is going up. On the left side, we don't talk about it. So that's the one you cross out because I can see the left side. There is no arrow that makes me wonder what's going on or what direction it's going. I can see the left side, it ends. Okay? All right, describe how the parent function is transformed. Well, I have an a value of 2. So that is a vertical stretch of 2. I have an h value of -5, so I have a shift left 5. And I have a k value of -1, which means I have a shift down 1. Okay? All right, let's do these guys, or this last one. You know what, let's go ahead and start with the description since we finished that one there. I have a 3 out front, which means I have a vertical stretch of 3. Remember, if that was a fraction that was less than 1, it would be a vertical compression. I have a negative inside. What does that mean? That means I have a horizontal reflection. That negative sign inside represents a horizontal reflection as opposed to a vertical one, which means instead of going up and to the right, we're going to be going to the left for this one. I have an h value of 3, which is a shift to the right 3, and I have a k value of -2, which means I have a shift down 2. So let's go ahead and put our h and k values in the middle. 3, -2, and again, I'm going to go 1 away and 4 away. So 1 away from 3 would be 2 and 4, and then 4 away would be -1 and 7. Now, one direction is going to give me those imaginary numbers, so I need to be prepared for that. So let's see. 3 times the square root of negative, open another set of parentheses, -1 minus 3. I have 2 sets of parentheses open, so I need to close 2 sets of parentheses, so it moves me out of the radical, and then I have -2. I get an answer of 4, so that's a good thing. That probably means that this side is the imaginary side, but I'll verify. Now I'm going to come back and change that -1 to a 2, and I get 1. Let's check the 4. If it's like I said, I'll get an error. Yep. And if I go back again and check the 7, still have that error. So this is giving me my imaginary answers there. So let's look. -1, 4, 2, 1, and 3, -2. Now this time, this is my stopping place. So I'm not coming from here and heading down. I'm starting always at that HK place. That's my vertex. and I'm heading the other direction. So my graph is going like this. Okay, so domain. Obviously, we're stopping right here at a domain value of 3. All of my x values are to the left of 3, so I'm going to say is less than or equal to, x is less than or equal to 3. And then my y values, they're stopping at -2, and everything is above there, so I'm going to say y is greater than or equal to -2. As far as end behavior, the right side, that's the side I'm going to cross off. I can see it. There's no arrow. It's the left side we're talking about, and the left side is going up towards positive infinity. Okay, so there's my cube roots and my square roots. On to my last two graphs, which are both absolute value. Absolute value, if you remember, is your V. Okay, I do not require an XY chart for these ones. So, the first thing I need to do, don't know why there's 2 periods there, don't worry about it. I need to find my H value and my K value. What's my H value? There's nothing inside, which means it's 0. And my K value is 6. So my vertex of this is 0, 6. Then I use the slope that's given to me, which would be my A value. That's a -2 over 3. So from here, I'm going to go -2, which would be down 2, and then to the right 3. 1, 2, 3. I'm going to do that one more time because it fits. That's half of my V. So starting from my vertex, that's the first half of my graph. Now, how do I find the other side of my graph? I go back to the vertex, and I still go down. I'm just going to do the mirror image, which means I'm going to go to the left 3 instead. So down 2 and left 3. These graphs should be super fast. So there's my absolute value. Domain, all real numbers. It's going left and right forever. Range, it does have a top place. It only goes up to 6. So all of my y values are less than or equal to 6. Okay. And both of these, both ends are going down. So I'm going to put negative infinity and negative infinity. As far as my description, I have 2 things going on. Your A value actually does 2 things. The negative A means I have a vertical reflection. And the 2/3, since 2/3 is less than 1, I also have a vertical compression of 2/3. Make sure you give me that value of the compression. Okay, I have no H value to worry about, but I do have a K value of 6, which means I have a shift up 6. And that's what we've got going on there. Okay. All right, next one. H is -3. K is -4. So my vertex is going to be -3, -4. -3, -4. From there, I use my slope. My slope is 2, which means I go up 2 over 1, up 2 over 1. That's the first half of my V. Then to find the other half, I go back to the vertex, go up 2, and then go over the other direction. Up 2 and over the other direction 1. Fill it in, and that's what the V looks like this time. So, domain, still all real numbers, going left and right forever. Range, there is a bottommost point right there at -4. So all of my y values are greater than or equal to -4 because they are going up. Okay, and both ends are also going up, so both my end behaviors get a positive infinity. All right, our description. My A value is positive, so I do not have a vertical reflection, but since it's 2, I have a vertical stretch of 2. I have an H value of -3, which means I have a shift left 3. And I have a K value of -4, which means I have a shift down 4. Okay. All right, on to the last batch. We are writing equations. Okay. 2 of these are cubics, or I should say cube roots, right here. And 2 of these are square roots. So I have 2 different equations listed here. Here's my cube root equation, here's my square root equation. They are identical except for the index right there. All right? Now, the b values, we're not going to worry about the b values too much. The only thing we could potentially have is a -1 for that b value. But this whole fraction thing, don't stress about that. All right? First thing we need to do is we need to find h and k, which on a cube root equation is your inflection point. So find those 3 points that are right in the middle, and the middle of that bend, write the coordinates of that point. That point is 4, 3. That's my h value and my k value. All right? So I have 4, 3 to start off with. Now I'm going to look at the box thing for everything else. Take your point of inflection and make a box. It doesn't matter if you go to the point to the left or the point to the right. I tend to always go to the right, but it doesn't matter. And tell me about the dimensions of that box. Now be careful. If they are not counting by ones, then that can change. This goes from 1 to 5, so this side has a width of 5. The height, however, goes from 3 to 3.5. So I have a height of 1/2. What does that tell me? That tells me that my a value is 1/2. The dimensions of the box, whatever's not 1 by 1, gives you your a value. And the reason why it has to be 1 by 1 is because in your parent function, that box is always 1 by 1. So we're looking for how it's changed. Now, my next question is there any kind of reflection? Now, with cube roots, it's kind of nice because a reflection, either vertically or horizontally, looks the same on the graph. So I can throw the negative sign on the a and not have to worry about putting a negative sign inside, which is a little more tricky. Square roots, I do have to worry about it, but with these guys, I don't. How do I know if there's a reflection? Look at your end behavior. On the parent function, right side is going up. On the transformed one, right side is still going up. On the parent function, left side is going down. On the transformed one, left side is still going down. If the end behavior matches, we do not have any reflection. So I'm going to put my a value and then my cube root. If h is 4, it's going to look like x minus 4 in the radical. And k is 3, so the plus 3 needs to be outside of the radical. That's the equation of my cube root graph. Okay? Let's look at this cube root graph down here. Again, find those 3 points that are pretty close in the middle. On your parent function, it's right here, those 3 points that are pretty close. All right? That middle point, that point of inflection, we'll abbreviate it I for point of inflection. That is -2, -1, because this graph is just counting by ones. So what does that tell me? That tells me my h and my k. Now I'm going to look at a box again, from the inflection point to any point next to it, to either of the 2 points, I should say. And I have a box that is 1 wide, but it is 2 high, which means that if the height is 2, my a value is 2. Okay? Now, to see if it's a +2 or a -2, to see if there's any reflection, let's look at the end behavior. Parent function, right side's going up. Inverse, right side's going down. Parent function, left side's going down. Transformation, left side's going up. So the end behavior has flipped, which means I need to make either my a value negative or my b value negative. And it's easiest to make your a value negative whenever you can. So I'm going to put my a value, and then I have my cube root. H goes inside, so if h is -2, it's going to look like +2 inside the radical. My radical needs to stop then. And then my k value, the -1, is hanging on outside there. All right. All right, down to our last 2. We've got square roots. Okay, so look at your graph. You should have an arrow on one end. Here's my arrow. The other end is your vertex. Identify your vertex first. That's the point 2, 0. That gives you your h and your k. All right? Then do your box. Again, the parent function will always have a box that is 1 by 1. If I do the vertex and the next point over, this graph does not have a box that's 1 by 1. It's 1 by 3. So guess what? A is 3. Now check your end behavior. This one was going up and to the right. This one is still going up and to the right. So I don't have any reflections. So I don't need to worry about those. I just need to plug all this in. So I put the 3. Now I do a square root instead of a cube root. H is 2, so it's going to look like a minus 2. And a k value of 0, we don't need to write. So my equation's just that right there. Okay. All right, last problem. Here we go. Again, look for that vertex. The vertex is right there, and that's the point 3, 6, which means that is my h and my k. Now look for your box. The parent function is always 1 by 1. This one right here is also 1 by 1. So I don't have anything that's making a other than 1. So a at this point is just 1, which we don't need to write a 1 in front because it's implied. Now, I do notice something though. My end behavior is different. Is my end behavior going from up and to the right to down and to the right? Because that would be a vertical reflection. If it's still going to the right, it would be a vertical reflection. That's not what we have. We have something going to the left. So it went from the right, and now it's going to the left. Well, right and left, if we're talking about opposites, right and left, we're talking about a b value change, which is a horizontal change. If we were talking right and right, this is the left to right direction is the same, but the up and down is different, that would change your a value, not your b value. So let's write our answer here. We have g of x equals, I'm going to write it over here because I think I'm going to run out of room, equals, a is 1, so I don't need to write that, square root of, now b is negative 1. That means I have to put a negative sign. I can't just go from there to writing x minus 3. I have to put that in parentheses. Whenever you have a b value of negative 1, you have to put this in parentheses. Don't distribute anything, just leave it in parentheses like that. And then your k value, the plus 6, needs to be outside the radical there. Okay? All right, so there is your practice for the Mod 10 test. Or if you're doing this for the retest, it's known as your qualifier number 1. Happy studying.